So this is lesson 21. We're going to talk about functions today. So to get a kind of brief introduction to what a function is, and these are things that you should have seen in the previous 2 years. We're just going to recap everything. And a function itself says that there is exactly one output for every input. So that means that if I have a function, and a function is kind of like a rule. So this rule has to be applied to this input. And when you apply this rule, the rule can't change. It won't change its output. So if I have a 3 that goes into this function, and a 5 comes out, if I put 3 in again, what should come out? 5. If I put it in 5 million times, the 5 millionth and first time after that, still going to be a 5. Because that is a function. It's functioning correctly. Okay? Now, if I was to go and put a function, take that function and put a 3 in, and I got my 5, and then the next day, I decide to go and put a 3 into that function again, and it gives me a 10, something's not right. It's not functioning correctly. Right? It's kind of like when you go turn your car on. You turn the key, car should start. Right? Or push the button, whatever kind of car you have. Or, if it doesn't start, it's not functioning correctly. I like to sometimes think of it as a vending machine. If I go down to the Pepsi machine, and I hit a Pepsi, I should get a Pepsi. If I go down and hit a Pepsi and get a Coke, you're kind of thinking, well, this thing's not functioning correctly. But then as soon as I hit the Pepsi button again, I get another Pepsi. Is that, oh, it's functioning, right? It's good? No. It would not be functioning right if it one time doesn't work. We're going to say it's not a function. We're going to get into how to test for that later on. Now, functions have variables in them, and we call those independent and dependent variables. You can kind of think back to your science classes on what an independent and dependent variable are. Independent variables are the ones that you control. They're the ones that you control. They're the ones that you change, right? You can change those. You directly affect the independent variables. Because if you think you're independent, that means you're in control. Which is mostly a teenager mindset, correct? But unfortunately, you find out that you are dependent. Because dependent is kind of at the mercy of what goes in. So, the dependent variable, I hate to use the word in it, but depends on what goes in. Now, I also said that a function's a rule, right? So, if I know the rule of the function, I could, by chance, control or change what goes in to forcibly get what I want to come out. Can you argue with that? So if I know the rule is that I'm always going to add 1 to it, and if I want to get a 5, well then I'm going to control what I put in and put a 4 in so I can get a 5. But you're still dependent on what goes in. You don't control that. Another name for an independent variable, we call that the domain. I don't think there's E in there. Is there an E in the end? I don't think so. Not like as in Maine, the state. Okay? And the dependent one would be called the range. We're going to come across those a little bit later on. And so you got to think back that they kind of are interchangeable, or they can use them or think about them in what's controlled and what's not controlled. Okay, so now we're going to talk about evaluating functions. Functions are rules. So what I want to do is evaluate or simplify by putting values into a function. x is function notation for saying something is a function. So there's going to be a test later on that I'm going to say, hey, is this a function, yes or no, and we'll have to test it. Or you're going to be given a set of data, and you're going to say, is that a function with those parameters, and you'll say yes or no. But if someone comes across and gives you a problem that looks like f of x equals 3x plus 2, I don't need to check, is that a function? Yes or no. You can just say, I know it's a function because someone already told me it's a function. You use function notation when there's a function. Now the function notation does not have to be f of x. It could be f of n, f of t. It could be f of whatever it needs to be, a variable. It also could be g of x, h of x, m of x, n of x. So it's going to take many different forms, but it'll have this idea of f or a variable with parentheses with something else. And what it means is that you're talking about a function, that's why we use f a lot, is a function made up of x's. But we also should know that f of x is the same thing as what in a normal equation? It's the same as the y. So this equation down here of f of x equals 3x plus 2 can also be y equals 3x plus 2. So when we go to graph it, a lot of times we're used to the xy coordinate plane. So that xy, the y is f of x. So you could call it x, comma, f of x, but then people start to get a little mixed up with was there x supposed to be there, is x not supposed to be there, so forth. So what does it mean to evaluate? Well, what you're going to do is you're going to take whatever is in the x's place in the function form, notation, let me replace that. You're going to take any of the x's in the rule and replace it with whatever is in the x position in the notation. Okay? So whatever is in, change the colors here, whatever is in this position right here is going to replace all of these with it. So if it's a 5, I take all the x's out of the rule and replace it with a 5. If it's a negative 8, I'm going to put them all in negative 8. If it's a t, I'm going to put a t in there. We're going to get to a couple examples of this. Okay, now we have a couple functions up here that I want us to evaluate. I want you guys to evaluate the function f of x, and it reads, the function of x's is equal to x plus 2. I want to evaluate or find, what does it mean when f of 1? F of 1. F of 1 equals what? The function evaluated at 1 is equal to? It is 3. But let's show what is happening, because if I don't show what happens, people are going to lose what to do here. So what's really happening is I take the x out and I'm replacing it with a 1. Notice I'm using replacement, I'm substituting, so I'm using what? Parentheses. Very important. And what is 1 plus 2? It's 3. So this is not that bad. I'm going to make a small change. It's going to be hard in here. Can I change that to a... I want to change that to a negative 5. It's a little hard to see. Just the fact that I want you guys to get used to the idea that we have parentheses there for a reason. Sometimes because we don't want to lose our sign. So what does it mean to be f of negative 5? It's negative 5 plus 2, which equals negative 3. Now I'm going to start to mess with you and say, what if I call it f of h? I just take the x out and put h. It's not that big of a deal. And so the answer is h plus 2. Now, how do I state this? Now, if you were to look, say, in the answer book or online, a couple other sources, they might not just say all of this stuff and leave it kind of laying out here with the 3, the negative 3, and the h plus 2. You might see them actually write this as f of h is equal to h plus 2. They restate it. They restate that if I put h into the function, it becomes h plus 2. Or if I do f of 1, it equals 3. The function evaluated at 1 is 3. Okay? Notice what I'm not going to do. I'm not going to go and say, oh, I'm going to divide by 1 to get f by itself. Don't do that, okay? You're talking about the function at 1. So the function at 1 is equal to 3. Which really what it does is it creates the point 1 comma 3, right? Because f of x, or f of 1, is 3. That's your x and y values. Okay, moving on to a little bit more complicated one. I added this one here because there's more than one x. And so, let's do f of 1 again. F of 1 again is 1 squared plus 1 minus 10. We have parentheses. In this case, the parentheses do kind of help us here because I have to do 1 squared, and 1 squared is 1 plus 1 minus 10, which ends up being negative 8. I hope you guys are not finding this to be difficult at all. And if I put m in, just like before when I put h in, it becomes m squared plus m minus 10. Now this, guys, be careful. What if I would have made that a negative m? It would have been a negative of m squared, which actually turns into a positive m squared, right? Because of our exponent rules. Be very careful on that situation. And it becomes m squared plus m minus 10. It's almost the exact same thing as x squared plus x minus 10, but it's just a different variable. Now my function is in terms of m instead of x. Now, I am trying to trick you now. What happens when it's f of 2x? Or f of x plus 1? No, I forgot to do my other one on top. I'll do it after this. This becomes 2x squared plus the quantity 2x minus 10. And what is 2x squared? 4x squared. Because I'm going to act like I'm distributing because it's a power of a product. It's 4x squared plus 2x minus 10. Still a function of x, but it has now changed. It's a function of 2x. So it's a new function. It's been changed. I'm going to go back up to the top there. Because I forgot to do this. This is going to highlight. It doesn't matter what I put into the parentheses. Whatever I want to put into the function, I can. It still follows all of the rules. So if I do this, f of Alex. So what does it equal? It becomes Alex, in parentheses, plus 2. Or Alex plus 2. That's it. I like to rewrite it with all the parentheses because they're not needed. If they were needed, because there'd be something out front, then I would keep it. Because if there would have been a 2 in front of that, then I would want to keep the 2 on with the parentheses there. Okay? Now, we do that because when we get to a problem like this bottom one with the x plus 1, what does it mean to be f of x plus 1? X plus 1 squared plus the quantity x plus 1 minus 10. How many people right now want to call that x squared plus 1? Why would you want to call it that? Because what do you have to do to that x plus 1 squared? You have to FOIL. Do not think that you can just distribute the square to the first and last term. Because that is definitely a rookie mistake now. You should not be making that. You guys should be recognizing that when something's squared, you have how many of them? You have two of them. You're multiplying together. Or, do you remember this? A plus b squared is equal to a squared plus 2ab plus b squared. That is a perfect square trinomial, but you don't have to remember, just like we talked about yesterday, but there are things that we'll do that will make it easier for yourself, a little less whining, if you remember some stuff like that. So, let's just go back to the old style foiling, because that's what you guys remember. X times x, x plus times 1, 1 times x, and 1 times 1 gives us x squared plus 2x plus 1 plus x plus 1 minus 10. Right? That's what it equals. I'm going to put an equal sign there. Gathering like terms, I only have one x squared term, yes? So x squared. I have two x's plus an x will give me 3x and 1 plus 1 minus 10. Minus 8. You've now just factored, or not factored, sorry, multiplied out and gathered like terms. You now evaluated what is f of x plus 1. What is the function evaluated for x plus 1? Yeah, it's all options here. I'm giving you guys all the different options that you guys will have to come across. Now, that bottom function, the function itself, its function notation, because it's saying h of 0, because sine, cosine, and tangent are functions. So this function says that it's sine of theta. So wherever you see theta, you're going to put it into h of theta. You're going to put it in sine of theta. And so I have 4 times the square root of 3. Is that going to change? No. But I do have h of 30 degrees. So that means I need to replace the h of 30 degrees with the sine of 30. So 4 square root 3 times sine of 30, because h of 30 should mean that I'm using the sine of theta, and theta happens to be 30, because that's what's inside the parentheses where theta was. If you don't remember what sine of 30 is, and hopefully by now you do, 1, 2, 3 square root. What's the sign? Opposite over hypotenuse. It's 1 over 2. So that means it's 4 square root 3 times 1/2. And what's half of 4 times square root of 3? 2 square root 3. Done. Now we're going to talk about finding the domain and range. The domain, again, I said, was independent variable, or the ones that you put into functions. The range are the ones going or coming out of functions. Yes? Now, there's something that we have to realize when finding the domain and range. You can't use numbers for x. Usually it's x is our domain, so if you want, put x there. And then usually y. But you can't use numbers that make it so you're dividing by 0. Or if there's a square root, that'll eventually make it so you're having to try to take the square root of a negative number. And we've known that for a long time. You can't divide by 0. What's 2 divided by 0? You can't do it. What's the square root of negative 13? Can't do it. Or you can, but you're going to get imaginary numbers. So we're talking about real number solutions. You can't do it. So, what does it mean to be domain and range? I'm asking myself, what can I put in and what can I get out? And so, if I pose this question, what is the domain and range of y equals 2x plus 3? There are certain functions that you guys have graphed many times. And so you should visualize what that is in your head. Without even having to do a proper graph for it, you should know what that is. What is it? It's a line with what kind of slope? Positive slope. And the slope's a 2, so you know it's a little bit steeper than, say, y equals x. So if I just quickly sketch it out, we know it's going to cross about 3 and go something like that. Yes? I don't have to be true on this. I'm just drawing a rough sketch, and there'll be arrows on both sides. Why do we put arrows on both sides? It goes on forever. So the question you're going to ask yourself is, when we did all these graphs like this, do we ever go and stop you guys and say, hey guys, you guys can make a t-chart, but you can't put this value in? Did we ever stop you from putting a certain value into the t-chart of a line? Why? Because it's going to be there eventually, right? I could put 1,000 into this function because 2 times 1,000 plus 3 is 2,003. That's way someplace, off the board over that way. Okay? I can put it in because it goes on forever in both the x directions and in the y directions. And so, the domain is all real numbers. The range, again, covers all real numbers. No, it's fine and dandy to state it that way, but that's not necessarily the way we like to state things. So I need to move to the next slide and talk about notations. There are 2 types of notation that we're going to use. We're going to use set notation and we're going to use interval notation, and I want both for your works. Okay? Now, I'm going to use the fact that x is greater than 3 as an example. Everyone should be able to say, hey, I'm going to make a line, and I'm going to say, is that an open dot or a closed dot at 3?
Open.
It's an open dot because it's not included, and I would have to shade to the right. That's what the graph would look like. That's the inequality. What would it look like in set notation? Set notation uses curly brackets to list the elements or to say what's in it. So that particular problem would state with a bracket x, we're talking about x, such that, that's why the straight line's there, x is greater than 3. And it reads as all real numbers of x. Sometimes what they do is they change it and say x is within this r thing. That e, that small e, means within such that x is greater than 3. So some books, some places you might look online for answers and help, might use that x is greater than r instead of just saying x. Because we're talking about x being some form of a real number, but it has a limitation and the fact that it has to be greater than 3. That's set notation. And those, we're going to work on those. It's going to change between different problems and different cases. If it's just all real numbers, you would state x is on all real numbers and you're good to go. Interval notation uses parentheses and brackets. Parentheses are parentheses, brackets are brackets. Now, when do you use each one? You will use parentheses when not included. You will use brackets, when it's is included. Okay? You use brackets when it is included. Now, we have on here, I had to change it because on my printout I had it wrong. 3 parentheses, 3, comma, infinity. Here's the thing. Can I be at 3? It's an open dot. Can I be there? No. So therefore it has to be a parentheses, comma, and where is it going? It's heading off towards infinity. But here's the question. Can you ever be at infinity?
No, you just keep going.
You just keep going. So you can never be at infinity. So infinity will never have a bracket. And so that's why it is another parentheses. This right here itself is what we call interval notation. Set notation, interval notation. In our homework, I want to start to see both of those. Because when you guys get to pre-calc, you're going to use it a lot. Homework is on page 159, 10 through 12, 16, and 25. Have a fantastic day, everyone.